Okay, hi and welcome to Video Notes 8.8, which is exponential growth. So what we've started with in the last couple of days is learning exponentials in general. What we're going to look at now is taking that general form. This is a general form for exponential. Y equals some initial amount, whatever we're starting with, times our growth factor, B, has to be greater than 1, right? We'll talk shortly about decay, which is anything that's a decimal, so that would be a decaying, so it would be shrinking. Our exponential is growing as a growth, and then raised to the x power. So that's what we're familiar with. But a lot of times, things aren't always doubling or tripling. A lot of times, they'll come as a rate. And you can see over here that there's a rate here. I just covered up the R, but that means R. So this rate then is in terms of interest, interest paid, percents. Growth will come in those terms where it's not something simple like doubling, which is 200%, or tripling, which is 300%. A lot of times it'll come in terms of a rate. So R then, or I guess what we're doing is we're taking B and we're breaking it up into two parts. The rate at which it's growing, rate of growth, okay, and that's our R. So it'll be some percent. So look for a percent when you see these. It usually comes in terms of some percent. And what we're going to do is we're going to add that to 100% of the original. And that sounds funny. But if you think of finding out like tax, when you have like your sales tax, whatever it is that you're taking sales tax on. So let's say it's $1. So we're going to take $1, and if we were charged sales tax on that, which is 6%, right? What we're going to do is, if you wanted to find the total amount of that, you could take and multiply 1 plus the rate, or 1.06, and it's going to tell you how much you're going to pay, or $1.06. Obviously, being $1, it should be just $1.06. And that's kind of the concept that we're going to work with. You could multiply by just 0.6, but it's just going to tell you 6 cents, and then you have to add that to $1. And oops, let me make that 6 cents. And if you add that to $1, it's 1.06. So this adding these two together is a way to make it one big growth factor. Okay, so that is B, 1 plus R. It is B. We're just breaking it up to 100% of the original plus R. What do you need to know is whatever your rate is, add 1. That's what you need to know. Whatever your rate is, add 1. So let's see that in action. And again, of course, everything else standardly applies. A's got to be greater than 0, because in other words, if that's 0, the whole thing turns to 0. And B's got to be greater than 1 to indicate growth. Okay, that's how we know that it's growth. When that changes, and it will shortly, we'll talk about decay. So now that we kind of have a general concept, what I'd like you to do, every problem for your homework, and I'll probably have said this yesterday, is I want you to start with that form, the basic form of the particular problem. And these are going to be rate problems. You can see right here, here's a percent that kind of indicates that. Write it down. It helps you memorize it. When you get to testing, that's not always given to you. So these are some common ones that you should know. So I'm going to expect you to do that on your homework. So make sure that you write that down on all of your homework to start. And then also on your homework, make sure that you identify each piece of that formula before you begin. So I need to see this at the top of your homework tonight and for most of the rest of this section. Okay, so let's read the problem. It says, since 1985, the daily cost of patient care in community hospitals in the United States has increased about 8.1% per year. Okay, that's our rate. Okay, so there's our R right away. So let's label that. And I'm going to write it as a percent to start. There's 8.1%. But to be able to calculate with a percent, we know we have to change it into a decimal. And as a decimal, we move it over twice, right? So it'll be 0 or 0.081. So that's what we'll use to calculate with this. Okay, so we've identified a piece. We stopped, called it out. Now it says, in 1985, such hospital costs were an average of $460 per day. Now notice that's kind of like a starting point. So this is your initial value. That's your A. So let's go ahead and label A, which will be $460. Okay, and then finally, T is the time frame, the periods, the number of events. Again, that's what exponentials are about. That's how many times it occurs. It doesn't really give us there, because the only question it asks us so far is write an equation to model the cost of the hospital care. We're just setting up the model. We're not solving. No solving. Okay, so let's set it up. We've got the two pieces of information. Obviously, T represents our x coordinate, right? And I'll even call it that, just so you know, that's our x coordinate. And when you make a model, right, you should have an x and a y variable there, because it's an input and an output. You want to be able to put different values in. So we're just going to set this up with y equals I'm going to put in my value for A, which is $460 per day. I'm going to multiply that by my base, which is my B, but B this time, don't forget, comes in terms of rate. So we're going to take 1 plus the rate, that'll be our B, and we're going to write that in here. I'm actually going to write it as 1 plus instead of combining the two, so you can see it going together. I want you to see it happen. And we know it's going to be 1.081, but I want you to see where every part comes from. And then T is our x-coordinate. So here's our output, our y, here's our input, our t, and that's our equation. So that's all we had to do for that first part, was just get the model written for us. Now, you'll see that B here is going to add in the part where it gives us our t value. It says use your equation to find the approximate cost per day in the year 2000. So it started in 1985. Now we're going to the year 2000. So to find t, it's going to be equal to the difference of those years, which will give us the time span. So this is what we'll do. We'll take 2000, subtract it from 1985. That'll give us a 15-year gap or time period that we're looking at. So remember, we said that t, or x, or x-coordinate, is time periods, events, whatever it happens to be. So in this case, we've got 15 years of time passing. So let's plug that 15 into our equation. Let me change colors just because I'm getting bored with the red. And we'll rewrite this. Now, let's do one other quick thing. Let's use function notation here, because we haven't used it in a while. In function notation, sorry, I got stuck on my spelling there. Function notation is good for showing that it's a function, so we can see the input and we can see the output. So we're going to change y to f of x. But instead of using f of x, because that would show an input, we're actually going to put in the value of our t, which is 15. So we're going to show 15 in there. So this says, instead of using y, we're going to say we're evaluating this function at 15. We're plugging 15 into it. That's all that says. We haven't used it in a while, so I want you to see it. We'll duplicate everything else that's up there. So here's our initial amount, $460 per day. Let's clean up that middle piece so it says it the correct way. So it's going to say 1.081. That's our growth factor. It's 100% plus 8.1% growth. So it's not growing super fast. It's not doubling like the paper folding activity, or it's not tripling like some of the other activities we've seen. And then, of course, we're going to plug in our 15 because that's what we're doing. So this is the part where you're going to want to stick this in your calculator. Okay, calculator. Don't make it any different from that. You can hand calculate it if you want, but obviously these are numbers that we want to use our calculator for. So let me pull my calculator back up here. I'm going to scroll it over. I want you to see what this looks like when we put it in. So when I go to enter this, I'm going to do 460, right? Because we're evaluating it, times, I'm going to use parentheses so it looks the same. You could use a multiplication symbol there. I'm fine with that. And then I want to go ahead and raise it to the 15th power. So that's what it would look like in your calculator if you're typing it. Just want you to see it. We'll go ahead and plug in enter. And so we find out then the function at 15 equals, let me pull that back up because I forgot what it was, $1,479.60 it looks like. So $1,479.60. Now, you'd think we'd be done, but we know that anything written into a word problem, the answer needs to be represented in context. So we're going to go ahead and write this out. So what we're going to say then is the cost of, and we'll go back, patient care, we'll use the exact terminology. Excuse my calendar there. I don't know if I can make that go away. All right, the cost of, let's say the cost, hold on, we'll get that corrected. The cost of patient care in the year 2000 is $1,479.60. And we could make that a little bit more explicit. We could say it's risen from 1985, which was $460 per day. But gosh, look at that amount. That's a pretty substantial difference in cost of healthcare. $460 to $1,479 per day. And if you guys have had any family members or close friends or anything that have been in the hospital that have talked to you about the amounts, you'll quickly realize that that's not far off, and that's in the year 2000. That's not even current. So you'll know that that's pretty accurate in terms of a model. We could take this out and we could change our 15 years and we could make it current. Instead of 15, we could make it 29 and find out what it'd actually be now. We'd see if that is actually accurate. It should be substantially larger than that, though. All right, so for your homework, not to get this video too long, again, just finish any of the book work that you didn't do from page 439, last night's homework. Go ahead and finish that up. Your video notes are done, and then tomorrow in class, you'll have time to work on this homework here. Okay.